Oh, hey there. It's Jenna. I don't know about you, but when I think of a car, I think of a heat engine.
But there's a heat engine in a refrigerator too. And this is my little friend Peter. He is a heat engine too. As you can see, his nose dips into the cup of water when placed near. But the question that remains is why? Let's jump into details. Right, Peter? Right. Most heat engines use the energy provided by heat to do work, hence the name. The work I'm talking about is not necessarily breaking a sweat, but rather the forces on an object to displace. In our situation, Peter moves freely to drink his water up and down thanks to heat? Now that doesn't seem right. It seems odd that he's able to move because the water that he was drinking out of was not hot at all. It was from the refrigerator as seen before. But essentially why he can move is via a thermodynamic cycle. In Peter's case, this happened when the water evaporates very slowly from his beak. But for any heat engine in general, this heat can be achieved through mechanical means. The general process of a heat engine starts by having a high operating temperature. Then the engine takes some of the heat used to raise the initial temperature to turn some of it into work and some of it into exhaust. Now the engine's temperature can be raised to start the cycle all over again. The amount of work done, however, is dependent on the engine's efficiency. What I like to call the thermal bottleneck, and also how many other scientists like to call the thermal bottleneck, it describes how heat dissipates while moving through a system. This is probably why I've burned myself touching a car engine. This all cycles, but back to the first and second law of thermodynamics. The first law accounts for the conservation of energy. If the energy is not being converted into work, it is coming to burn my hand. And the second law helps us determine the efficiency, like mentioned before. There, interesting enough, is a way to define the energy that is lost. It is called entropy. It mentions the disorder in a system, such as the flying heat particles lost due to exhaust, as mentioned before. When energy continues to transfer and transform, some of it is inevitably going to be lost. Something else on the matter is refrigerators. They are ironically heat engines, but they obtain the required heat via the heat of vaporization. The refrigerant, which evaporates in our refrigerators, forces the operating temperature to move from a cold to hot area. Whether it be car engines or Peter the drinking bird, these inventions help society work, quite literally.